Three, two, one. Aloha and welcome to the SolarCoaster live show here with Jason Vericart in from Osaka recently. Welcome, Jay.
Pleasure to be back, although this isn't the first.
Yeah. And we're kind of getting the studio all worked out and it's all dialed in. That's thanks to Jay, Mr. Technical over here. We looks a lot like a radio station. And we've got some amazing guests on the show today. We've got SolarEdge, some wonderful execs in from SolarEdge to talk all about our recent experience with the SolarEdge Home. So why don't we start out by introducing ourselves. Michelle, maybe you could say hi and tell us a little about who you are and what you're doing at SolarEdge.
Yeah, Josh, thanks for having us. So I'm Michelle. I'm the sales education manager here at SolarEdge. Been in the industry for 12 years. So finally on the manufacturing side with, in my opinion, the best manufacturer in the industry. So happy to be here.
Welcome, welcome. And we also have Chris in, and I was just trying to figure out if we've connected in the past years or not, but Chris is apparently a super knowledgeable fella here. Chris, why don't you introduce yourself?
Sure, great. Well, very excited to be here. My name is Chris Thompson, Vice President of Product for North America for SolarEdge. So work a lot on voice of customer and new product introduction, and excited to talk about our products today with you.
Excellent. Welcome to the SolarCoaster. So just so you know, we've been privileged, Jay, to have SolarEdge. I'm going to say SolarCoaster and SolarEdge throughout this show. I'm going to intermingle those two terms. But we've had great guests and relationships over the years with various people at SolarEdge. And not only that, but I was in a former life an installer. I owned a small installation company here in Maui, and we often installed SolarEdge technology. In fact, I remember on his house, I installed his house. Not me, I didn't actually do it, but I put the business guy. And I remember Manny Lugos coming out to, can you that name ring a bell?
Yeah.
Coming out to Hawaii. I mean, it might have been, geez Louise, like 8 years ago, 10, I don't know how long ago. And he came out and he was talking to me and he's like, Josh, SolarEdge is great. You got to try it. And he was giving me like incentives to try it. And I was like, I don't know, a new technology, what's this? And now come full circle, like darn near a decade later, and you all are pretty dominant in the residential inverter marketplace, and especially out here in Hawaii, and for a lot of the reasons we're going to talk about. And so it's really interesting to see that full arc. And then for me and for Jay to both have the technology in our homes, I think says a lot. So that's kind of a bit of background there.
there's that. And in the interest of full disclosure, I have to say I'm also a stockholder. So.
Oh, wow.
Well, thank
and
you
I'm glad
guys.
Manny took one for the team and went to Hawaii for us to really sell the product. So I still haven't gotten an invite. But
really. Okay, fantastic. So we're going to dig into now, it's kind of a unique type of podcast we have here, because in this is really the culmination of a long working relationship with SolarEdge and the SolarCoaster. We've just come out of, to disclose the kind of the whole thing, we've just come out of installing the SolarEdge Home on my home here in Makawao, Maui, upcountry Maui. And we've also had an opportunity to work with that system for a couple of months, better understand the daily usage of the system. And we had, I'm going to slightly let what is that phrase? Let the
cat out of the bag.
Cat out of the bag. Thank you. Let the cat out of the bag and say that I just experienced an outage with the technology, and a pretty momentous outage at that. It's an unprecedented kind of thing that happened here in Maui, but we'll get to that a little later. So this thing that we're just finishing up here and wrapping up in a sense is kind of unique for the SolarCoaster. We're oftentimes kind of going, hey, tell us about your technology, Mr. So-and-so. And then, so we're learning, but we're also going to be sharing some of our experiences here. This started, and I'll definitely try not to be too long-winded on this, folks, but this started with a conversation with Lior Handelsman. I believe he's one of the co-founders of your organization in 2019.
Yep.
At Salt Lake City, right, Jay?
Yep. We were there interviewing. It was a fantastic shot. He was going over all the interesting parts of the technology, including the EV charger integration, maybe some future tech that we want to get to at the end of the episode, even back then. And the invitation was there to try it, and then things happened in the world. It took a little longer to get there, but here we are, and you've been experiencing it for the last.
I sure have. And I'm going to pass this over to you guys in a second. I just want to say that it was at that moment in time when we met Lior on the show floor in 2019, and I think it was in Salt Lake at SPI. Yeah. That I remember looking, and he said, "Oh, we acquired a battery company." And I was like, "Whoa, these guys are going to be dangerous in this market," because now you've got this dominant inverter with these dominant efficiencies. You've got this in-house battery, the lithium technology. They were moving to the EV charger and other technologies as well. And I was like, "Wow, that is a heck of a integration of technologies."
Yeah, it really is that vertical integration that makes things attractive. You don't want to have to deal with this company's thing talking to that company, and they never actually quite work well, and then everybody's pointing at everybody else. Well, ours is standards compliant. It doesn't. No. So it's great to have one badge on the product.
Is huge. So that was kind of how it all began. But I want to give you guys an opportunity here to jump in and kind of say anything that's on your mind here about the technology itself. You're really in an interesting position, both of you, Michelle and Chris, to be working with this technology as it really starts to launch the SolarEdge Home. So are there any kind of, maybe Michelle, maybe you can tell us what your thoughts are on this tech and being right there in the belly of the beast, so to speak, as you go after this market with this amazing technology?
Yeah, I think it's interesting that you bring up 2019, because that actual advent of all of this SolarEdge Home product is what brought me to SolarEdge as well. So I was on the residential sales side, and the thing that was the biggest challenge for me was we were never able to go back and sell anything to homeowners. It was always, the homeowner had to decide if they were going battery today, or it was going to be an expensive retrofit that made no sense. And this really changes that dynamic. So, you can add batteries today, you can add batteries later. The EV charger coming out is just a no-brainer because it's fully integrated into the solar system. And we're going to have these smart energy devices coming up soon, as well as generator support, which has just come off the ground as well. So it's really truly an energy ecosystem that, like you said, is streamlined. It's challenging when you have to work with other products, and it's kind of I think we all know in the industry, kind of Franken solar. It's like we're reacting to other people's technology a lot of times. This is, oh, you liked that, Josh? You haven't heard Franken solar? You heard SolarCoaster.
It just, I get flashbacks, of end of NEM, post October 2015. Oh no, we have to put together on grid battery solar plus systems, and then everybody and their brother coming out to Hawaii. We can do this, and we're like, okay, great. And then it's just woof, not.
Yep.
There were days when he was literally in my backyard, lying in the grass, crying.
Okay.
It was that good.
That out.
Too much.
Chris, why don't you jump in, sir? So
yeah, well, from my perspective, I tend to focus on the technology probably, but two really exciting things I think about this launch is, the term integrated ecosystem, I think, is finally being manifested here. And one of the backbones of that is the communication system. So we've got this energy net communication system. And so one of the things, not only is it an integrated systems, but it's just much easier to install now. And so one of the things that we saw in the past is these disparate solutions. It wasn't easy to get them to talk to each other. And this communications network isn't just for sharing information and getting, feedback to monitor the system, but it's also part of the controls for the system. And so that now we have this, it passes information to make decisions. When should I charge my car? When should I charge my battery? When should I backfeed into the grid? So the backbone of the ecosystem is really the communications network. And I think we've really kind of revolutionized that with a platform that is, fast and agile for working in this kind of environment, but also is robust enough. So that's really one of the things that stands out for me. And then I think more and more over time, we're also seeing the value of a DC coupled system, because, when it's just PV, right, you could achieve safety in different ways, but now that you add storage to it, our technology philosophy is if something's natively DC, then keep it DC. So PV, of course, is natively DC. Your battery is natively DC. So if you want to put PV into your battery, why would you convert it to AC and then convert it back to DC to get it into the battery? And then when you want to use it, you get to convert it back to AC again. So you're doing triple conversion. When if it's DC, just go DC, do direct. So it's much more efficient. It's just much more sensible, much more practical. So we're seeing, as the ecosystem grows, the value of DC coupling systems, especially for things that are natively DC. And right now it's PV and storage, but in the near future, it's really EVs are natively DC as well. And so that's as we go forward a few years, that's really going to be one of the biggest things that's going to be part of the home energy ecosystem.
Yeah, I think it really can't be overstated though, that control of what gets what energy when is hugely valuable, because you don't want to get up in the morning and find out that your EV has sucked your home battery dry, or or the opposite is, you didn't get enough energy to drive to work in the morning. I mean, all these things can happen. So where do you value the energy direction?
There needs to be some intelligence there, and otherwise you're kind of like one of the off-grid guys out in Hana, which was kind of pioneered over the last few decades, or maybe 4 decades. Hana's the east side of Maui, guys. So, and out there you had all the off-grid guys, right? But of course you didn't have any EVs, but you certainly had kind of really compromised living. You could only have so much power, so much storage. I remember looking, because I would go out there and see the old systems, and they'd have these rooms. They were building rooms for batteries, right? It wasn't like you hang a battery on your wall. I mean, that's what a luxury, right? Now that we get to put a battery right here. I mean, this was
big framework of car batteries.
Go build me a room to put my batteries, so I can have a very modest amount of A, power, and B, energy that I would need to change.
Refrigeration working,
right?
Lights on,
right? Yeah. So yeah, I'm really excited about the technology, and I want to jump over a little bit to exactly what the equipment is on our home here, if I may. And so we cover it. We did some shorts. We did a series of videos, which I'm excited to share with y'all on this. But the technology that we chose, I thought, was really elegant. And that's from a guy that's seen a lot of different equipment, seen some things work okay, some things work well, some things designed in a way that and very few of them were designed in a way where I go, ooh, that's an elegant design. I like that design. So it had to do with the DC coupled. Chris is like, yeah, I see what he's talking about. So the DC coupled architecture is very attractive, right? Even before we get into kind of the future leading stuff, which makes it like even more attractive. But what's neat about this system from my perspective, and I'm going to introduce the term now so I don't forget. I want to use the phrase abundance of energy. I want to use that phrase. And what I mean by that is since we've had electricity, we've been generating it centrally. We've been running copper wire on dead trees and bringing it to our home. And then if something happens, like the wind blows or a storm comes, it goes down, and we go, oh, we don't have energy. Maybe we plug in a old Jenny or something, And so you had that kind of dynamic. Now we're in a situation where we've got this abundant potential for abundance of energy. And what I mean is, if you think about the DC coupled architecture, you have all this, you don't have the problems of inversion and rectification unnecessarily at a given moment in time. But you also have some really neat capabilities. For one of the things that we have in this system is this 200% DC-AC ratio, right? Isn't that neat? Because then you go, well, PV is relatively inexpensive, supply chain issues aside. And so you can put one inverter up, right? And then you can oversize the DC to that, right? By 200%. And I've never seen a ratio like that before. I saw 1.2, 1.3, 1.5, and it kind of inched up. But now all of a sudden you get all this potential energy on roof. And I don't have a 200% DC AC on the 11.4 yet, but I will. But right now I got like 10.5 kilowatt DC up there, about 3350s to give you some context. But what's exciting about that is there's so much potential energy. And then the question changes from how do I get energy out here to what do I do with all the energy I have? And that's the concept of abundance of energy that's been bopping around in my head. Oh, see, I'm getting excited.
Yeah, you're excited.
I'm hitting the mic. It's been bopping around in my head ever since we started this conversation with this very elegant technology. So to hook Josh on this, you get me off the stage for a second. But the bottom line is we got a 10.5 kilowatt DC system, DC coupled system. We've got a SolarEdge gateway, which is kind of the brains of the whole operation and backup interface. We've got an 11.4 kilowatt inverter, right, which is the largest residential inverter that I've ever seen in market. And then we have one 10 kilowatt hour battery bank. And we also have the EV charger, which is, I think, about 11.5 kilowatts. I made sure that the installers, my good friends at Jackson Electric, ran the right gauge cable so it could be at that peak 11.5 kilowatts, I think was the charging, 48 amps or something like that. So that's pretty much at the max of the onboard sizing charging for current EVs, like all those guys out there. So that's the system we have, everybody. Okay, you got it in your brain. You got the system in your mind. So that's what we have. And the installation, of course, was seamless. I've been through the installation process of these technologies in the past. Really, the integration of the gateway, the EV charger and the battery was darn near plug and play. Not much more than that. And so that went really well. And now the system itself, I'll add on to this, and then I want to jump back over to you guys, I'm set up as a self-supply system. So that's kind of unusual in the broader world, I think, right? Of PV systems. First of all, we got batteries, we've got backup interface, we've got EV charging, we've got this big DC-AC ratio, which has energy abundance, all the things I just said. But now we have self-supply. So what does that mean? Bottom line is I'm not backfeeding any energy to the grid. I'm buying from the grid whenever I want, and I'm trying to mitigate what I buy with my solar plus battery system here. Yeah. So that's kind of the status of the system. But I want to give you a chance here to jump in. Do you have anything you want to say about that, guys?
Yeah, a few things. So first of all, I'll commend you on going to a high DC to AC ratio. And I think sometimes it's an underappreciated feature in the industry, but I think you've kind of connected with some of the value of it, but there's some really interesting byproducts of it. So first of all is, one of the thresholds we run into in many homes is what is the size of the load center. And so, for example, I live in a kind of old home and I've only got a 100 amp load center. And so when I go to add things, I really think about it. And so what a DC with that high DC to AC ratio allows you to do is use an inverter that's perfectly sized to your home. So in my case, it'd be like a 3.8, a 200 amp. That's pretty common. It would be a 7.6. And then you can get a lot of PV on the roof and not trigger that main panel upgrade. And of course, as you probably know better than I do, a main panel upgrade is quite expensive. And it's also very disruptive to the homeowner because you need to take the power down, you need to coordinate with the utilities. So from a scheduling perspective, it can really be a disaster, because, it's very location specific. Some utilities, it's easier to coordinate, some it's not. So there's a lot of costs, a lot of schedule risk and timing from it. But also when you think about having a high DC to AC ratio, in many cases, you won't actually have a lot of clipping because, for example, I know if someone's listening, they won't see it, but you got a roof and you got arrays on both sides of the roof. The sun's not hitting both sides of the roof simultaneously. So you can say, well, I have a very high DC to AC ratio, but I'm really only using one array at a time, perhaps.
Right.
And so you get the optimal, and when you think of your production curve, you kind of get the wide shoulders of the curve. And especially with everything we're seeing in California lately, we're learning that right-hand shoulder of the curve is incredibly value. Everything is about those several hours at the end of the workday, from 4 or 5 o'clock to 7 or 8 o'clock. So being able to widen it out. So you kind of get that benefit. The other thing too is, if you are over generating, then that's when you can put it, if it's a DC coupled architecture, then you can put it into the battery. So you get that ease of installation, avoiding a main panel upgrade, getting to put any potential clipping. So I don't think we're at this point yet, but in the last few years, we've kind of been trained to think about like AC coupling or DC coupling. Now, I think in the future, the concept is not going to be AC coupling or DC coupling. It's going to be decoupling, meaning you've got an AC ecosystem and a DC ecosystem, and they may be decoupled from each other. The inverter is the interface between them, but you'll have PV that could directly go to your battery or directly go to your electric vehicle.
Wow.
And of course, so DC going back and forth on the DC side is incredibly efficient, and AC staying AC. So I think
these two worlds kind of living side by side.
Exactly. So PV to EV directly is the most efficient way to charge, by far. And so like I said, I think that's a few years out, but that'll kind of be, the future ecosystem, I think, in the home is being able to decouple.
That really ties it together in an interesting way because it is directly related to the eliminating or reducing the need for those meter upgrades and the installation complexities that all of this new kit can require. And then you move over to the notion of, well, DC coupled allows you to do these different things, but really fundamentally different, I guess, right? Because if it was an AC coupled system, you probably could have a meter upgrade issue. And then you would be looking at, within the case of the EV, now you've got kind of these, you're doing a lot of charging on high power, relatively speaking, and you got relatively big losses as a result of that, right?
Yes.
That's
Yes.
what happens, right?
Yeah.
So what it blew me away, because I didn't get this out of the gate, fellas. Like the notion that you could take, let's say, for example, and correct me if I'm wrong here, and we're comfortable kind of doing a little quasi math on air, if you don't mind. But so the basically, 'cause I'm okay to be wrong, but if you had 22.8 on roof, which to me is like bonkers, that's 3 times the size of the average system I would have installed back in the day. 22.8 kilowatts, which is the 200% of the 11.4, right? And then if let's say I had 2 batteries, they charge at 5 kilowatts each, right? So then I could conceivably charge those in DC at 10 kilowatts. So 10 kilowatts of that 22.8, correct me if I'm wrong, could potentially go to those batteries. And then now we're sitting at, what did we say again? 12.8 after the 10, 12.8 sitting around, that could go to as much of that as possible go through the 11.4 inverter. Basically, maybe could go to the EV charger. I think it's at 11.4, 11.5, right?
Yes.
So you could simultaneously charge your EV at full onboard charging capacity, meaning the thing, that bottleneck that's potentially there in the EV itself, and those 2 batteries, they could be both getting on one single residential inverter full charge at a given moment in time in a place like Maui. How do we get to that point? I mean,
well, and simultaneously, you're also only putting it on one breaker. So, I talked about the solar installation trigger a main panel upgrade. It's the same with EV chargers. So an EV charger could be a 40 or 60 amp charger, or if it's not, it could need a 40 to 60 amp breaker. And the EV industry runs into that same challenge. You say you have a charger, it's $500. But if it triggers a main panel upgrade, all of a sudden that charger now becomes $2,500.
Right.
And that becomes a pretty strong disincentive to actually get an electric vehicle. And so in the case with ours, we put that landing point on our inverter. So rather than putting that in your load center, which is very valuable and may trigger the upgrade, we actually put it onto. So you get that inverter that would only take a 40 amp breaker, but you also get a charger there as well as the battery. So you're kind of almost like triple stacking. So you really get high utilization out of a single position in the load center. So it's all kind of like stepping back, looking at the whole ecosystem. How do you avoid the main panel upgrade, and how do you get the most charging? And in a little cute side note to the charger, when you put it at the inverter, one of the rules on a breaker is you have to derate it by 20%. So that breaker that's normally feeding a charger, we can supplement that other 20% from the inverter side. And so you actually get full capacity out of the charger. So it's kind of like turbo charging your charger. You get an extra 20-25% out of it. So it's a little bit faster. And then of course, when it's on that same ecosystem, kind of going back to the communications, right? You can schedule it, and you can say, okay, when do I want to charge it? I want to charge my vehicle only from the sun. And you can do that.
Right. We're actually at a place in time where that
coordinate those
could happen.
I'm extremely valuable.
Yeah. There's a lot of value here, and you touched on. I know that the Hawaii market is important to SolarEdge, and you already have a tremendous presence here, and so there's probably opportunities for people that, like Jason, that has, I think, 2 3/8 on his home.
Yep.
His home is like way bigger than mine, and I've got the 11.4, and he's got these 2 3/8 on it.
Trade if you want.
Well, no, I want to keep my 11.4. So, but there's opportunity here for in Hawaii, and then of course, Jason is a NEM system account holder, right?
Okay.
Early adopter, let's call him an early adopter.
Sure.
Good for him.
Josh had to go and get himself, home a little later on down the road, and then install the systems that I was selling for so many years. And so I'm a self-supply system holder, right? Which is really not much of a tariff at all. It's basically saying, hey, I'm going to produce my own stuff here, and then I'm going to buy what I need to buy from you. But I was just looking at my first couple of months of billing, and it's remarkably effective with the battery. I'm really looking at, coming down from in the hundreds, $300-400 territory, even more sometimes, because there's some hot tub and spa and stuff, and then down to really like in the 20s and 30s, like that kind of that kind of distance. Now we are geeking out like no one's business on a self-supply system. So we're loading up the dishwasher at night, we're loading up the washing machine at night, and then we're pressing play at the middle of the day at the curve and just grabbing all that extra energy to try to get as much of the potential energy that's out there as possible.
By loading up, you mean just putting stuff in it, not actually running it.
Correct.
Just so we're clear.
Yeah, no, we're not running it until the daytime energy curve is present. But the whole family's kind of gotten into the idea of it.
Yeah.
Oh,
yeah. You gamified it. Completely.
Gamified it very much. And then of course the EV is the next stage, and we're kind of like eyeballing EVs super serious right now. Mm-hmm. So yeah, it's an exciting time. Now, are you seeing in the marketplace out here, what's the Hawaii market look like for you all? Are you thinking about this technology? I mean, it seems to me it's like it's a no-brainer for a lot of people.
Yeah, well, the Hawaii market is really interesting, but the first thing that kind of comes to my mind is Hawaii is really the most advanced of all the states in thinking about grid interconnection, because it's kind of like a large microgrid in many ways. So, the mode that you're referring to, what might commonly be called the MSC mode, or maximize self-consumption. Oh. And I think that was a feature or functionality that was primarily driven out of Hawaii requirements and Hawaii use cases, to maximize that kind of autonomy and independence. Because if everyone's producing and backfeeding the grid, and then everyone's taking power off the grid at night, it doesn't balance the whole ecosystem of the grid entirely. So Hawaii is of course an interesting and exciting location, but from an electrical perspective, they've really pioneered the market. And so in many ways you can look at what's happening in Hawaii, and I think it's a foreshadow of what happens in many other regions around the world. Sure. Especially as an inverter vendor, the features and functionality that are embedded into the inverter are maximized the most in Hawaii, probably more so than any other market, even California.
Right. And we are a part of the HECO battery incentive in Oahu and Maui, which is a huge deal. It sounds like Jason might need to expand his system. Yep. And one of the big advantages of the HECO incentive as well is that if you are a NIM customer, you can expand that system up to 20 kW additional if you need to expand that system. Big deal. So are you ready to go, Jason? You think we need to connect you?
I think we definitely need to have a conversation once this show is over. But I did want to bring that up. It's like, what does the upgrade path look for someone like me? I already have solar. I've had it, been very happy. But the NEM system works the way it is. I feed into the grid. I get a retail tariff back on my bill. So what I generate just offsets what my grid buy. It's pretty neutral, but it's not. I mean, we still have the pool and things that suck a lot of power, so it's not. We're still buying. It's just it offsets 100% of what I would be paying for grid buy. Mm-hmm. That said, there are things that the NEM system doesn't do. Like when we have a power failure, everything goes off. And there are very good reasons for that, right? You do not want to be shocking someone who's trying to reset and repair your actual electrical service. So it shuts itself down. But it's a big negative when we have a large power failure, and they do happen. In fact, I had another one just regionally over here, like three days ago. Was not related to the Big Island wide outage. Just this part of the island has iffy service. So interesting. So again, what does that upgrade path look like for someone who's already bought in and wants to upgrade? Is it?
Yeah, I guess the question would be, could he simply get a gateway and a battery and then call it a day, or are we switching out that inverter because you need to have like the certain model? I mean, because they're
I'm thinking it would have to be able
5-10 years ago we put that
communication
in, right?
protocol that they're all now talking, and I don't know if it's aged out in that way.
Yeah. So, without looking at the system, there's typically, a couple of paths, but it sounds like the system you have is an older system and doesn't have battery capability. So you can buy a battery and you can buy an inverter, that goes with it and run those in parallel. In some cases, it's easier to just buy one inverter and put the PV and put the storage on it. So I'd say in most cases, it may be easier to do that. Then you have them all going to one inverter. So it's just in terms of fitting it on the home. Mm-hmm. and fitting all the electrical equipment together and stuff like that, that probably is a little bit of a cleaner approach.
I would definitely go with 7.6 inverter. That's my favorite one. Has 200% oversizing, gets you up to 15.2 kW on a 40 amp breaker. Real easy.
Wow.
To get that streamlined, sexy setup like Josh was talking about on your house with one inverter, the ability to add other batteries. Forgot to mention the actual incentive for HECO's $4,000 up front. So, great time to get a battery. And to your point on backup versus, actually using self-supply, if there are outages, you can just set up that battery to backup mode and not discharge it. So you could keep it charged if you were just using it for blackout emergency situations. But if I were to give any recommendations, I would do it on my house. Just switch out that inverter with a home hub, and you can have it all on one inverter with that expandability option.
Yeah, and with some of the new features, you can kind of capitalize on both the resiliency as well as the grid optimization. So, that incentive is one of the most attractive.
It sure is.
Probably the most attractive in North America that I can think of off the top of my head. So it's very attractive, but kind of what it does is it signals how valuable that storage is, not just to you, but to the utility that you have that capability there. So there are a diversity of ancillary services, and that's a very high value to them. But with new alerting systems, if we detect that there's a storm front coming in, like a day ahead of time, it'll say, hey, we're detecting a weather situation. And then you can automatically switch it, say, okay, I don't want to charge and discharge based on, an ancillary service I'm providing to the grid. I want to make sure my battery is filled up and always filled up. So whenever over the next 24 hours that resiliency event could happen to occur, then you get that. So it will look at the weather and it will give you that warning, and then you make that decision. So you can make a real-time decision, but it doesn't wait till after the event has happened. It'll do some weather forecasting. It's as accurate as weather forecasting is. And then you get that notification. And so you're able to really get the benefits of both of those types of functionality.
I was wondering about that, because I knew that would be almost a requisite part of the plan and technology for that to work, right? So, and one of the things we try to do with the SolarCoaster and have for years is take these kind of complicated ideas and distill them down to something that kind of my mom or Jay's mom, because we get the calls after the shows usually from our moms, can say, oh, I got that, right? Yep. So, but in Jay's case, and just correct me if I'm wrong here, but basically he's got an M system and he wants, let's say, energy security is a part of that desire.
It's the next big thing, and then EV charging comes shortly, close second.
And then after that, you would want more PV,
bidirectional,
because you would want the extra. Okay. Hold on, Jay. Get the bidirectional. Jeez, I'm trying to recap here.
I know.
So you get to, let's say you've got an M system, your bill's good, right? A lot of people, early adopters throughout Hawaii. And now you're going, I really would like to have a little energy security in this battery bonus program. They're going to give me $4,000 to put a battery in. That's amazing. I want to do that, right? So, and what you just said, Chris, is really important, because it's saying that the utility is going to be using that battery basically, I think, between 6 and 8 p.m. kind of at the bill of the duck curve, right? The way the energy curve looks. Yep. And they're going to use that for a couple hours, but they're going to pay you in advance and some form of credits, I think, as well, if I was reading the lines correctly. So you can get that battery for when you need it in an outage. And you don't really need it every day if you're on an NEM, because you already got a theoretical battery in the grid, right? So you're kind of good with your NEM system. You get a battery. In alternative to this, you'd have to go and buy a battery, and it would kind of just sit there and not do very much, which is a waste of a battery. So the battery bonus program kind of opens that door for people and says, hey, we're going to subsidize you getting a battery, and and we're going to use it a little bit during the day for what we need in nighttime, rather like the 6 to 8 p.m. period. And then when you need it for your energy security, you're going to be able to use it too, right? It doesn't, like, one doesn't negate the other.
Yeah, it's not a seesaw where you have to compromise one or the other. You're able to do both. And really, the other thing too, alternatives that utilities can look at is they can put peaker plants in and other things that in many environments just aren't really viable these days.
Yeah.
So
nobody wants them anyway.
Nobody wants them. You can't get them permitted. They've got noise emissions, they've got air emissions, they've got pollution. There's a lot of things associated with them. So it's better for the environment, it's better for the homeowner, it's better for the utility. So it really is a kind of
awesome. It's awesome. So there so there are two more pieces of the puzzle. Michelle brought this up. There's a 20 kilowatt expansion capability when you put that battery in, right? Michelle, is that what you said?
Yeah. So for the NEM customers, that is available.
Huge. Huge, because for years, NEM account holders, Jason, you were kind of in a size lock. You couldn't expand.
Yeah.
Now all of a sudden we get this new program that says you can expand.
And the reason why that's so critical is because of the burgeoning EV
And
market.
the next
like,
stage
nobody was thinking about getting an EV way
Right.
back when we were doing early NEM, but now they're ubiquitous. You need this thing in your life.
It's
And
amazing.
the only way to be able to power it with solar.
It's amazing. So now you get all the things we just talked about. And the last stage of that is because there's an integrated EV charger and you don't have all the upgrade problems. We already covered that. Now you can also put the PV on to accommodate this new load.
Right.
What an interesting and also I would say elegant kind of program that's available. It's just awesome. I'm so glad to see this because there were times where these things did not exist, and now we're in a place where you're the choice, you have the opportunity to do a lot of things,
Yep.
It's really radical. It's exciting. It's an exciting time. So, okay, we've covered a lot of ground already, but we actually still have plenty to talk about. So I want to talk about, before we get into power outages, I just want to recap the expandability, kind of the parameters of the expandability, if you don't mind, right? I think about this kind of stuff a lot. So, and the reason for that is in Maui and for Hawaii, some homes like mine are kind of modest and, 3-bedroom, 2-bath, kind of 1,500 square footy kind of home. And some homes are massive. And people may be thinking, well, can this technology work for systems of different sizes? And it looks to me, by my read on what this system could expand to, that you could actually approach some of the largest homes that I'm aware of and that I've sold to in the past. So tell me if I'm right on this or jump in at any moment, but that one gateway can handle up to 3 inverters. Is that correct?
Yep.
Right.
And then it can handle 3 inverters, and then each inverter can handle 3 batteries.
That was the next.
So you're looking at 90, close to 100 kilowatt hours per home, which is I can't quite say. I think I've seen that maybe once or twice. It's a pretty uncommon. So normally you can get by
a
with
tremendous amount of energy. But I asked you exactly that. If you look at this side of Mr. Porter's house, there's the battery, the inverter, everything else, and the battery's way over here. Why did you do that? You left a big gap.
Yeah, well, maybe I want to put in more batteries in the future, or maybe I want to put in more inverters in the future, or maybe I build an Ohana and it's on the same service, Ohana, right? The Hawaiian way we talk about little ADUs or additional dwellings, in residential. You can put up to 2 ADUs on a R3 or a residential a TMK out here. So I was kind of thinking about expandability and how to make sure that it was, there was plenty of room there. So, but what I wanted to add in the question here, Michelle and Chris, is that the 3 inverters can accommodate 9 batteries, 3 each, right? And then we get up, I believe we get up to 10 kilowatts, 5 kilowatts of power per battery. So 10 per inverter max, because you can't actually get another 5. So 30 kilowatts of power. Here's my question. In off-grid mode, can you get 30 kilowatts of power under that circumstance in off-grid mode? Did I do the math right?
Yep, that's correct. Yeah, 30 kilowatts of power, 90 kilowatt hours. So pretty substantial.
So you could charge your
Having 3
EVs
batteries
during
is actually a better way to run the batteries too, because you're not stressing them.
Sure.
Discharge.
Yeah. But just thinking theoretically about it, limits, right? You could technically during an outage power your EV really easily, right?
Yeah. So one of the easy things to do in this installation method is if you have the EV chargers at any one of the inverters, which is pretty common. And so that interface box that holds 3 inverters is called the buoy, or the backup interface. That will isolate you from the grid. And so you'll be isolated from the grid. You'll be generating your own PV, running on PV and storage, and your level 2 charger will be on the inverter side. So you're disconnected from the grid, and that whole ecosystem will be capable of running. So if you've got PV, you can charge your vehicle, or you could discharge your batteries into your vehicle. And if you got one battery and you've got a big truck EV, then you're not going to put too many miles onto it.
There you go.
But you still have that complete capability to charge your vehicles off of PV in a very efficient way, and hopefully in the not too distant future that vehicle will be more bidirectional. We don't see too much of that right now, but I think it's
coming.
It's coming. It's in the next couple of years, and we're seeing early signs of it now.
I do have a question just to cap that out before we jump over to outage land. So you can have, you said it, an EV charger per inverter. So in this circumstance, let's say you have 3 inverters and you're maxing it out for whatever reason. Can you now have 3 EV chargers?
Yeah, you can have 3 EV chargers. Yeah.
You could charge three EVs during a power outage. Right?
Yeah,
So,
that's
what?
a little excessive.
So okay, so
Hey, it might be feasible eventually if your spouse has an EV. People are asking in the home, can I have two EV chargers on my home? You know, so I think we're seeing that more and more.
Yeah, no, 100%, Michelle. I remember when EVs started to become, they became popular out here pretty fast, right?
Mhm.
Because we have expensive gas and we have expensive, electricity.
And
Those are the two things.
short commutes.
Yeah, so people were right, and so the range anxiety wasn't so much of a thing on island.
Right.
And I remember people saying to me, we're talking about 5 years ago, easy, maybe more. I want to get multiple EVs. Can you size the system for me?
Mm-hmm.
I got that really early on, and now we're in a place where it seems completely feasible from both, but not only from an on-grid perspective, but also from an off-grid perspective. And that brings I think that brings us to the conversation of energy security during outage and what type of opportunities there are with that. Because what I just experienced the other day was the first time Maui had I've been here for 14 years.
Mhm.
First time that I've ever experienced a whole island-wide system outage.
Yeah.
That was on August 23rd.
Yep.
It was the other day. And so and I can talk all about how that worked and stuff like that. But what's remarkable is that I experienced that value of energy security, firsthand. Right? It was really it's a what a feeling that is to know that your home has power. It's just a crazy thing. So, did you guys hear about that power outage we had?
Yeah, how long was it actually down on your house?
Yeah, so it was about 2:45 a.m. Power went out. There was an arc flash in Maui, the primary power generation station.
Wow.
Yeah, yeah. And I wake up generally around 4:30, 5 o'clock, got my old man schedule going, right? I'm up and I'm going, oh, what's going on? And I'm looking at the house. I'm like, and I'm in my fuzzy 4:45 a.m. kind of mind, I'm going, something's different. I'm not sure what's different, but something's different. And then I go outside and I kind of look around, and dog's doing his thing. We're on a little farm here, kind of mini farm. Chicken's doing their thing, cat doing her thing, his thing, dog doing his thing. So they're all talking to me, and I'm like, quiet down. And I'm looking out, but my lights are on,
Mm-hmm.
but a couple of my things are off, right? Because I have a
Loads
control
panel.
mechanism. I have a
Partial
span
home backup. Yeah.
yeah, span system. So I go, what's going on? And then I look outside, and man, Maui is dark.
Wow.
Like
Wow.
all the way down to the valley. We can kind of see the views of the.
You can
of
understand.
Kailua.
You can see the town and the airport, and they're on 24/7. That's
Ugh.
the lights are always
Right.
there. Light pollution.
Yeah, and I'm like, oh my goodness, we're in a massive power outage. Because usually it would be like a section, right?
Mhm.
A line went down because of wind or whatever. So I'm like, whoa. And then I go, oh, what are my
Your
batteries? And I
neighbors.
check everything, and I start thinking to myself, get the cameras out, start to record. I gotta get it,
Yeah.
gotta get it on.
Yeah.
But it's 4:45. I hadn't had a coffee yet. And I think to myself, I need to make coffee, but I know what my coffee takes to make. And I'm like, I'm not spending that kind of energy right now. I got some coffee in the fridge. I'm gonna grab and have an
The
ice.
valuable cup of coffee, probably draws 1,000, 1,100 watts.
Exactly.
So.
It surely does.
Yeah.
It surely does. And so I sit there, I get my coffee going, I look outside, I see my neighbors. Check this out. My neighbors are flipping their breakers trying to get their house to work.
Outside
right?
on the side of the building going.
And I'm like, I
They
wonder,
think it's their house. It's not the house.
I wonder why he's doing that, because it's obviously a power outage. Then I look around and I go, oh, it's me.
Yeah. Massive confusion in your
He's like, why
neighborhood.
does he have power?
Mhm.
And then probably a lot of jealousy at that point.
maybe. Yeah, I didn't bring it. I almost said something that I felt kind of bad. I was like, hey, there's a power outage, but I have a battery, so don't try to flip your breakers. And I'm like, nah, it's gonna come out wrong.
You won't have a battery.
I'm not gonna say that. I'll just hold this one out. So yeah, and then basically now I have a small reserve, like 15-20% reserve on a 10 kilowatt hour battery, but I have very low running wattages. So it ran through to the morning, it dissipated. It discharges, the word, right? Discharged down to zero. So it went beyond my reserve the way it was meant to go. my load control panel basically curtailed my load. So I had even less running wattages than I typically have. And then I got through to the day, and then the grid came back on, maybe I think around 10 or 11 or something like that. Everything reset. And then we were back in business, and we were, charging the solar was charging the battery, and everything was going the way it was supposed to go. But I hesitate to say cool, because it was inconvenient for people. But what an interesting and amazing thing to finally experience it firsthand. It was awesome.
And that's kind of the way it's supposed to work. You mentioned something that we didn't talk about too much, but that's kind of on the load control side. So now that we have more load control options, right, you have that ability to say, okay, for example, like, one of the controversial loads could be an air conditioner.
Oh yeah.
And you may say, okay, well, if the sun is up and I'm producing a lot of power from PV, then maybe I'll run my air conditioner. But perhaps later in the day, I wouldn't want to run if I was on battery. So you can do those condition-based decisions, and that's the intelligence. And Michelle mentioned in the beginning about like the app, like that's really where the complexity in the brain is, and really the app is the interface to the cloud. Over the last, since the company started, we have over 100 million devices in the cloud right now. All our optimizers, all our inverters, so we know voltage, current, temperature, power of all these devices. And so it allows a lot of decision making to be made. And so you can run your home, abundantly when you have abundant solar, but then at night, you may say, okay, well, I'm going to be a little bit more frugal with my energy and go to restrictive modes. I'm a little bit of a Star Trek geek. And you know how sometimes they say, like, they're in a battle and they say, okay, divert all energy to life support systems, right? Like, that's when the battle is not going well. Right.
That's going to be my new Alexa command. Divert all energy to life
support system. So that's kind of what your load control can do at night. And everyone may have their personal preferences. Maybe your coffee maker is a life support system in some cases, and maybe someone else, it's a hot tub. I don't know. That's a personal preference. But load control really kind of closes that feedback loop, and really, and the other thing that's part of it is, and not all systems do that, but ours, when the battery goes to sleep at night, it goes into a very low power mode, and it will wake up automatically from sun in the morning. And actually some systems actually don't do that. Some people may take it for granted, but if you don't have that integrated ecosystem, you actually see a lot of those systems won't kind of communicate, and the battery may self-discharge at night. And so that's one of the benefits of that ecosystem I talked about earlier, is it will automatically wake up as soon as there's sun, and it'll start charging that battery and run those loads that you selected.
So we're Michelle, it's probably a good time to think about some of these newer, like maybe the roadmap forward. So we have all this this kit that we just described, and we're using it. It's not theoretical. It's right here, right? And we're using it in scenarios too, like we just described, daily and then outages. But I know that we've got smart plugs on the horizon, and I know that we've got Jenny integration on the horizon. And I did some math during the outage, because I was thinking, what if this is a super like apocalyptic event? I don't know what's going on. So I have 124 gallons of propane out front. I have a generator. So I was like, I wonder how many days I'm okay. And ran some math, so we can talk about that. But so, what's the product, or what do they say, the product path,
product roadmap. Yeah.
What's the roadmap forward? What's going on? Not to mention we're on the heels of RE Plus. I mean, can you spill the beans on something on the SolarCoaster?
Well, I mean, I can spill the beans on the fact, now that you mentioned RE Plus, we will have a huge booth there for our SolarEdge Home, as well as our commercial products and the roadmap pieces there. So definitely, if you're at RE Plus, stop by. We're going to have a huge booth with a lot of presentations. In terms of the roadmap, Chris kind of did talk about the load management a little bit, but those are those smart switches and relays that are coming out. We are at phase 1 of generator support right now. I will hand that over to Chris, since he is the pro and expert on products. But I think the main point that I want to drive with everyone listening is this is all in one app. And if you do want to see what's going on, Josh has it in real time on his house, which is great. But if you don't have this on your house, you can still download My SolarEdge. It's an app. There's demo sites on there that you can take a look at and see how these systems interact with one another and these different components, to give you an idea of the real management and visibility that you have on this system, which is truly exciting. Chris, do you have anything to add in terms of generator support specifically? Because I get that question a ton.
Yeah. So I'll talk about that for a minute then. So generator support, we kind of separate into different levels of generator support. And so the one that we're offering right now is that your inverter can run separate of the generator. What we found is a lot of generators are pretty low quality. The most common generator is a pull cord generator. That's kind of what I had, and it tends to the frequency, the voltage in some of these things are not always very stable. And so what we do in those particular cases is we will, allow you to run on inverter. And then, if at the end of the day your battery goes down, then the generator would run, but they would run separately from each other, not in a combined system. So what we're looking at in the future, if it's a high quality generator where we would be able to synchronize directly with the generator, but we're finding right now that most people are actually fine if it just runs separate from the generator, because we're going to use a kind of a relatively low cost pull cord generator. Those seem to be the dominant form of generator by about 10-1.
Yeah,
from what we can tell.
That's
So,
pretty much the kind that I have right now.
Yeah.
It's like less than $1,000. You buy it at Costco kind of thing.
What would be super attractive though is, and we all know that the best and most efficient way to run those things is at full draw. So what you would do is turn the generator on, charge your battery again, and then.
But that's going to be, that's like phase 2, right?
Yeah. That'll be the future generation of it. Okay. Yeah. And of course, the issue, many of these pull cord generators, you can't automatically turn them on and off because they're being manually started.
Right.
And so this a bit of diversity there. Yep. And so that's on generator support, but also, coming up at the show, we talked about load control, and I'll highlight. So the load control modules that will show there are based on the wireless energy net ecosystem that I talked about a little bit. And so the nice part about that is if you have a hot tub outside, you can put that load controller outside at the hot tub, or you could put it at the air conditioner, or you could put it at that load center. By making it wireless load control, you have a great deal of flexibility on the location. So you pick the loads, but you also pick the location on where you choose to control it from.
What occurs to me right there that and I was excited about the smart plugs. Is that the term you're using, smart plugs?
Sure. Yeah, the smart plug. Yep.
What's interesting about that is there's a let's call it a substantial installation requirement for smart panels, right? And so a smart plug, especially when you go and you target the let's say the larger scale loads, like Chris just mentioned, that's I bet you that's a pretty small investment. Am I right?
The plug's the easiest. I will say though, the discrete load control modules actually are quite easy to install. And so there's a couple of things about it. One is it's self-derived power, and two, it's wireless. So say you've got a wire that's going out to your hot tub. You go any place you want to do it. If you want to do it outside, you want to do it inside. But basically, you cut the wire and you put the end in the module, and the other end of the cut goes in the output of the module.
Right.
It's perfectly in line. You don't need to run a communications wire.
I got you.
You don't have an external power supply. It's completely wireless and self-derived. So when you want to do discrete loads, it's surprisingly easy to do that. And we do find, if it's a plug-in load, okay, that's easier because it's plug-in. But the bigger loads that you may want to control are not actually a plug-in load anymore. It's going to be hardwired.
Thank you for that clarification. Just what I understand here is you've got two separate types of load control products. You've got a smart plug, and you've got, what did you call it again? It's for a given circuit, essentially.
Yeah. So what we call is the first part we're coming out is a smart dry contact. And so what that does is it adds intelligence to a contactor. And like I said, so it all goes as a module in line. And in that way, so that there's one connection on the input and one connection on the output.
And that's for like a given circuit, like maybe your hot tub.
That would be for a discrete circuit. Yes.
Right. And then, okay. Yeah. So that makes sense to me that'd be pretty easy to install. What I was referring to is an actual panel, because I just watched the installation of an entire panel, and while I think the technology is marvelous, it's actually pretty involved. It took
reinstallation
of an entire panel, right? And I have it all time lapsed, and it's even the time lapse is long.
It is, yeah. So there's varying degrees of control a homeowner may want.
Yeah.
Now, when we do installations, we typically find in most homes, and you can each think about this in the context of your own home, typically most homes have like 2 or 3 loads. And if you can just control those 2 or 3 loads, you get substantial control.
From a percentage basis.
So for me, I've got an air conditioner, and my clothes dryer is electric. you know,
Right.
but most loads you just need a couple. So you can go something that's, you know, a smart panel full upgrade, but it sounds like you've seen the installation. And, you know, and the metaphor of doing open heart surgery is kind of relevant because it's kind of like the electrical heart of the system. You've got a bunch of connections in and out. The problem is when you do the heart replacement, the new heart is bigger than the old one. So sometimes it triggers like a construction upgrade because the other one was like this big and you're upgrading it and the new one's bigger.
Yeah.
Right. So sometimes it's smaller, you know, or
They're
sometimes
cutting
it's
some
deeper.
holes and stuff like that.
Yeah. And,
Yeah.
and so it ends up not just being an electrical project, but a little bit of a construction
Yeah.
project.
Interesting.
So I think, you know, kind of comes down to each homeowner and each installation and what would be needed to provide the value. But,
Right.
you know, the loads in the home are interesting over time in that they've bifurcated a little bit. And what I mean by that is like lighting used to be a load.
Yeah.
Now because it's LED, it's kind of a rounding error. It's to the right of the decimal point.
Sure.
And it's the same with
So
even
low.
TVs. Like you used to have TVs, but now they're flat screens. And so those are very low loads. So you have a large number, right? And you know, your phone chargers and other things again are unmeasurable and quite irrelevant. But then you've got a small number of really big loads. So it could be like, okay, I got an air conditioner and I've got a clothes dryer and, you know, maybe a hot tub.
Oftentimes the thermal things, right?
Yeah, you tend to be the thermal loads. And so kind of what that means is with a small number of load control elements, you can control the vast majority of the home.
Mm-hmm.
And so that's why I think from you know, a cost and practicality, I think, you know, a practical installation will be, you know, Michelle mentioned like the 7.6 kilowatt inverter. That's a very commonly sized inverter. You can put a lot of PV on it. You can put a lot of DC battery on it, you know, and then just a couple of load control modules, and you probably get everything you need to do full home backup and manage those big loads. You know, we tend to think of them as always, sometimes never. There's the loads you never run. There's the loads you always run. And those loads sometimes that you run are the ones that you put on load control. And in many cases, it probably will just be a couple.
Yeah. And so we covered a lot of ground in this, didn't we? Man,
Yeah, a little bit.
Amazing. And, you know, I am using the app on a regular basis. I check it every day. By the way, if anyone's looking to kind of like get out of social media, get one of these systems, because you'll start looking at this a lot more when you do look at like Facebook or Instagram. I want to see.
It certainly matters to you.
It's more interesting, right? You know, than all that nonsense. So it's really been it's a great app. I love it.
Yeah. And say again where folks can get that.
Yeah, you just go to the regular app store, you download My SolarEdge. So that's the kind of the homeowner facing consumer app. You don't need a login. You can check out those demo sites on there.
Yeah.
Nice.
And the thing I would add to that, you know, we talked about the Hawaii program, but there are other states doing programs similar to that. So Utah, Arizona recently started a program, and we see some activity going on in California. So the model that Hawaii has had for a while now, we're seeing it in other states as well. And the incentives are attractive. And a lot of those you can start that enrollment process, you know, right through the app. And so it's economical for the customer. And of course the utilities really value it as well. You know, I think the events just over the last couple of days in California with the heat wave,
Right.
and when we've had, you know, thousands of batteries supporting and participating in those events to help support the grid.
Nice.
And it's something that I think has contributed to help maintain stability in the systems.
There's 2 points that I wanted to bring into this just for homeowners to be able to feel. We covered so much ground. I mean, I think we covered pretty much all of it. But on the generator front, once you're at the phase 2, if I can call it that, like I said, I was able to do some math, and I realized that these Jennies run a couple gallons of propane an hour. And it charges at, you know, 5 to 10 kilowatts. So you could conceivably recharge your battery when you get to that stage in a very short period of time. And so I could see, and I just did the math, and I was like, I think I've got about a month on curtailed loads of power without solar. You know what I mean?
Yeah.
So apocalyptic, call it apocalyptic, right?
Yeah.
Let's say
Yeah,
that
no solar, the sky goes dark, but you don't have to fill that tank for a month.
or even, or
That's the critical
very
piece.
practically, like we get a hit with a tsunami or a hurricane, which hurricanes never seem to hit Maui, knock on wood, because the Big Island gets in the way of them. But if it would actually hit us, and then the system went down because we had, you know, huge winds or something, then could actually live off of the propane in the generator and the system itself, you know, until it was fixed for a very long period of time. It kind of blew my mind how all the system, what type of
And I think
value
if
it
it's
creates.
sunny, you should be able to do that indefinitely.
Yes.
I use the example often, you know, I grew up in New England and we had hurricanes, and what normally happened, the power would go out because the hurricane would blow down trees. And a lot of New England is pretty old and the lines aren't buried. And even if your neighborhood had buried lines, the lines feeding your neighborhood were above ground. And the next day would be sunny, but you would still be on generator for a week
Right.
because they were
Right.
chopping down trees and they were, you know,
Now you
rehanging
got
up
solar.
poles
Yep.
and stuff like that. You know, now if you had a snowstorm with 2 feet of snow, then, you know, you may not have solar and you may need to run on generator. But I think in many cases, you know, we've seen customers experiment a little bit where they'll install a system and they leave that disconnect switch to the grid open.
Mm.
And they just kind of like look and see what's going on. And they find like, oh, you know, at night my battery went down and the day the sun came up and it charged back up and I ran my loads and they'll just run their home disconnected from the grid for a
Right.
little while, almost as a little game
Yeah. They're
to,
like,
to
wow,
see to see how they can do that balance. And
Wow.
of course, then if you add in you know, load control, you could do that in an even more granular way.
a lot of
Yeah.
So cool. Independence here. And the second point that I wanted to just bring up in terms of the Hawaii market, the battery bonus program. And now I will say in my old at the kitchen table kind of language, I am not a tax professional, so I cannot give tax guidance, but I will say this, there's great value with the battery bonus program set up with adding PV, because the PV, the battery, you have the tax credits on the state and federal side out here, which are really robust, probably about half. And then you add that battery bonus program to it. Holy moly, you're like,
You're getting
you're
close.
you're
Close to free battery.
There's a lot of it's been subsidized. You might be in the 60-70+% subsidized territory. Just a guess, not a tax professional, but I do think that is a remarkable opportunity. And if I were someone like Mr. Verkert over here, I'd probably jump on it right away. So I think we covered some fantastic ground here, folks. Jason, Michelle, and Chris, is there anything that we want to add before we wrap this up? Are there any messages to the Hawaii listeners? Any messages to the people at RE Plus? Anything else that we should have covered that we didn't get to?
Yeah, I would just say, like Michelle said, we're going to have a great showing, a great booth. Come out and visit us, stop by and say hi. And we look forward to seeing people there.
Yep, that was really what I was going to add too. If you need additional training support as well, though, I do want to plug Edge Academy. So we do have certifications on our battery. If you're thinking about installing that battery, you can become a certified installer through SolarEdge for our SolarEdge battery, as well as sales certifications as well. So through Edge Academy, you can get all set up and ready to go.
Fantastic. I will let them have the final word there, unless Jason would like to chime in at the end.
Say we'll see you there.
Yeah.
Great.
Good.
Excited to see you guys.
Been our pleasure. Hey folks, this is been the SolarCoaster live show here with Jason Verkart, Makawao, Maui, just pre-RE Plus with great folks from SolarEdge, and coming off our first real tangible real world experience with products in home.
Finally get to play with the toys.
We get to play with the toys, and we loved it. And thanks to everybody, especially to Lior and Connor and Jill and everybody else at SolarEdge that I really appreciate everybody over there. So thanks guys, and aloha to everybody out. See you later.
Bye.
All right, I'm gonna